Okay, so let me just set it up with this. Why is it hard to teach this type of thing? And the basic thing is, well, first of all, you can't teach it the same way that you teach other things, particularly like math and physics. Most of that is taught very prescriptively. In other words, we say, here's a proof of something, and let's follow the examples. So we assign examples, and then people repeat it. But in this case, you're trying to teach someone to do something that you're welcome to come forward to, by the way. Okay, no problem. Okay, but in this thing, like, we're trying to teach people to do things that are new, that haven't been done before. So it's not necessarily repeating the, like a way to do a formula or something like that. There's something else that has to be done here. Not to mention the world has changed, and things that used to work may not work now. So you're in a kind of a live situation. Second thing is, if I give you a book and I say, tell me everything that's in it, and I can test you for it, that doesn't mean you can do these things in real life either. So we're struggling with those two things. And then you can look at the environmental factors. So here's two cities in the United States. Neither one of them is Silicon Valley, but they both have similar amounts of money, Chicago and San Diego. They have both equally good educational institutions. Smart people are working, the economy is fine. All of that is happening, but San Diego has something like 300 new companies that come out every year, and Chicago has a very small number, like less than 10, something like this. So there's something else going on besides just whether you're smart and there's money. And that thing I'm going to make the reference to is the way people interact with each other, their behaviors, kind of an innovation culture. You can put all those ideas around it. And so somehow that has to be also part of the way that these things are learned, taught and learned. So here's a couple of fundamental concepts. I'm going to switch to, I think this is for everyone, both from a student point of view and from a faculty point of view, and just tell you a couple really, I'm going to say in some ways fundamental things, but also, even though they're so fundamental, some of this took me a long time to figure out. It wasn't obvious to me day one. And so this part is fine. There's 4 things that people usually do when they start something new. They create a team, they have a story, this is what we're going to do, they validate that that story is good, and then they execute. When we do it in school, in classes, usually this is what happens. We spend a lot of time making the team, a lot of time making a great presentation, a little bit of time checking that the presentation's good, and we spend no time executing, okay? Now, just keep in mind that this is exactly the opposite of real life, all right? So in real life, it's kind of more like this. The team, that was important, story, that's fine. You should spend a lot more time figuring out that that's a good story, but really, making something work, changing, innovating, is about the execution. And that takes more than logic, it takes more than a good plan, and it takes me back to those things about behavior, how people work with each other, all the mindsets, and even the word execution is some of those things. It's something that people don't really understand. If I just ask you randomly, what does it mean to execute? I say, okay, here's something you got to do. How are you going to execute it? What does it mean to? What does it mean to do that? And I'll say, in some ways, people either have different ideas of what that means. It's at least a question mark, and it's worth a little bit of clarification. So a lot goes into execution, and it's the hardest thing to teach, frankly. Okay, this thing is a simple graph, but it took me a long time to figure out. And it's not just because it takes me a long time to figure things out, okay? So this goes to the idea of execution, all right? There's different ways that, let's just take a little example. Let's say you're a team of students and you want to start a company, or you're a group inside a company and you want to start a new project, or anything that you want to start new. You're a couple of professors and you're thinking about a new activity center or something, whatever you want to do that's new. There's kind of 2 ways that progress happens. One way that happens is up the vertical axis here. which I call progress in technology or product, or it's kind of logical progress. So, you basically have a good plan. It all makes sense. And that includes, do people want it? Logically, they should. I can almost like prove it. It means, does the technology work? Could I show you the demo works? Could I build it? All of that is logical progress. There's another type of progress that people can make, and that's called social progress. So social progress means all the people who are stakeholders in whatever you're doing, have they bought into it? And have you influenced them in a way that they support it? Because you need other people to be part of whatever you're doing. And the little jump that you have to kind of make is, whatever you're building, it's not just that you're building it. At the same time, you're kind of throwing a social event. It's like a party. And the question is, who's coming to your party? Like, do people want to be at your party? Now, like, this sounds very kind of high level or whatever, but it's very practical, okay? So what happens is, you take a group of engineering people, they will usually make a lot of progress up here, and everything is basically like all set, and then at some point they realize it's just them. There's nobody else that's like connected to this. They might even have the thing working, but there's no customers, there's no other stakeholders, there's no partners. It's how do you get the social progress at that point? And then they start thinking, who else do you need on the team, or do we need to change something to invite more people to be part of this? The other way that progress gets made is on the social dimension. Business students tend to be much better at this, okay? So they don't start with the what is it that we're going to make and how does it work. They usually start in this dimension. They tell the story to a lot of people. We could do this. We could make it work like that. We could get this person to be an advisor. We could build all the social proof and get a lot of progress, and everyone says, oh, that's a fantastic idea. We're all completely bought in. The only thing we don't have is like a product. Like, it's like everything else is ready. Like, everyone wants to be part of that party. Like, they feel like they've been invited. They're part of it. It's just you don't have the logical execution part. And it doesn't, either way, you have to get to both. So some people start off with something brilliant logically, technically, and then they find a way to get the social part, or they start off with the social part, and then they realize there's another set of people, but somehow both of those have to happen, and you get to the successful version. This happens in practice, because it's very practical. You think about it, it's like you want to create something new. Part of your time is the design of what you do, and the other part of your time is going and telling all the people what you're working on. And if you do that in the right balance, you get stakeholders while you're coming up with the good ideas, then it comes together, right? And if you spent too much time on one side or the other, you're confused. You're like, it's such a great idea. How come nobody's part of it, right? That's where it goes wrong. Okay. So if that's what we're trying to do, and keep in mind, if you want the social part and the technical part, then social capability, EQ, behavior, mindset, you can see where they play the role. Because it can't be only the logical progress. You have to make both kinds of progress. All right, so how do you teach something like that? Okay, these are all really helpful. And we teach these things all the time. I've been teaching them for years and years and years. Reading business cases, no problem. It's a skill I learned over time. I love a lot of cases I teach, but management practices, making these presentations, ways to get ideas, all these things, that's great, but by itself, that doesn't solve it. It doesn't solve both of these things. In some ways, these are good things, but they're at the surface. And I want to get a little deeper into what makes people able to do these things. Now, this is a slide which you may have seen, and I tend to repeat it because it's very fundamental to the way I think. And it basically says, in addition to those other things which are all helpful, we have to look at people and develop them as people in order to be able to do these things. So if you look at this chart, and you can say, you, me, everyone here, we're somewhere on this map, which means we're strong in that technical or that skill area, we're strong at math, we're strong in engineering, we're strong in finance, whatever our skill is. And the other one is the social capability. It's your psychology for innovation, and I'll describe that in a second here. So what happens is people who, and universities are really good at filtering for people who are up at the top of this. They're very strong in their academic disciplines. Whether they happen to be broad or narrow on the x-axis is a little bit random. Like you might be or you might, but we don't check for it. We don't filter for it. So we definitely filter for the vertical axis. We don't filter on the horizontal one. And so what happens? You can be successful here if you're really narrow and smart and good at something. You can make money, you can be successful. You can actually be good in this version too. This is like being street smart. You know who to talk to, you know how to get people to help you, you can organize with other people. Those people can have skills and you can get them to work with you. So you can get a lot done that way too. But what we try to do in our teaching method is to take people who are up at this point in the spectrum and move them to the right. I always say, if you're up here at the top and and you're in a group of people, like you're in a company, and all these people are very smart in their discipline, and one person is just like a little bit farther out. They're just a little bit on this other axis. What happens to them? And the answer is basically they become the vice president. They become the manager, the director, the vice president. They're not getting promoted because they're the smartest engineer out of the group of engineers. They're getting promoted because they're basically about as smart as the other really good engineers, but in this other dimension, they've shown ability to connect. They've shown a lot of necessary behaviors to be effective, successful. So our goal is, can we get you farther out? And if you can get all the way out here, I think of that as being like Steve Jobs. Like you have the ability to tell a story, you get people to see what you want them to see, the vision, you have a good sense of what they're really feeling, they want this, no, they didn't really want that. You have that, and you have like a logical strength in like, oh, this could be built, this is how you build it. All of that put together. Sometimes one person cannot be all of those things together. And this is important to understand too. So sometimes you can be here and you can move out in this axis, you can maybe end up here. But if you can appreciate a person who's maybe over here, not so logically, technically strong, but they have some of these other skills, if you can actually develop good relationships, trust relationships, if you can bind with them together, you can actually emulate that capability that's in the star. And this is really what good team formation is about. Another way to say that is like the diversity of the skills that come into the team. All right? All right, so what are these skills? I'll just review it quickly. If we wanted to, we could literally spend the rest of the hour or more or semester on this list. But just start off, wide comfort zone. What does that mean? That's your ability to work on things that you already don't think you're good at. So if you think, I need to take a class and know everything about it before I do something in it, that's a narrow comfort zone. If you're like, I'll figure it out. Just drop me into that situation, that's a wide comfort zone, right? Wide comfort zone is very closely associated with growth mindset, which basically means that you're not so focused on who you are and this identity and I'm good at this, and you're more focused on what's to be done. And you're like, whatever is to be done, I'll adjust myself, I'll get there, all right? Generating trust, that's another really and by the way, both of those are very correlated with innovators and entrepreneurs, just wide comfort zone. Generating trust, that's your ability to open up enough that people can trust you, and it's your ability to trust other people. If you don't trust them from the start, then it also doesn't work, and they can tell that you don't trust them. There are there are ways to generate trust, but just your ability to do it is important. One reason why it's really important to generate trust is that when people trust each other, they share information faster. So I have an idea, and I trust one of you, and I say, I just had an idea. And then you say, oh, that's not a very good idea because of this and this. And I get feedback. And then I say something else, and then you give me more feedback. Our learning rate becomes very high. When I don't have that trust, then it takes me some time. I think, maybe I'll tell you, but I don't trust you yet. Okay, now I will. And now it took a long time for me to get that feedback. And so when one group trusts each other, their learning rate goes up. Another group that doesn't trust each other, it's a slower learning rate, and this group is going to win over that group, right, organizationally, right? Good connectors, this is people who can connect with many different kinds of people, and this is related to two concepts. One is low social barriers. So we all want to talk to people who are similar to us. It's comfortable. But talking to the people who are different means you have to lower your social barrier. It relates to this idea that all the value comes from people who are different than you. So if you talk to a person who knows exactly what you know, they know all the same people, you might be able to have it parallelize work, but you can't get new things. You can't get, oh, you know a person who has that problem, I know a person who could solve it. That kind of value comes from lowering social barriers. Okay, so good connectors, being able to communicate that information. Inductive learning. Inductive learning is your ability to learn from the environment instead of like prescriptively from a book. I'll explain more in a bit. I don't, okay. Maybe I should just say it right now. So inductive learning is kind of a capability that you have when you're a kid, and school slowly tends to take it out of you, all right? So what happens is, when you're a kid, someone said, you somehow know not to touch the stove when it's hot. You didn't read a book, no one gave you a lecture on it, you just figured it out. And how do you figure out? You kind of put things together. You observe some things, you saw somebody burn themselves on something, another day you connected, that's kind of like the stove, and you just said, I'm not going to touch that. Some people probably still do. Okay, but, yeah, they have to learn it themselves. Okay, but when you go through school, what happens is that you're given the formula to so many things. So you're like, here's the knowledge we've learned, apply it. Here's some knowledge we've learned, apply it. So you start to think that everything that you need to know has to be like given to you, like it's somewhere in the book. And like if we could say, all right, in physics, take this apple, drop it off a tree like 500 or 1,000 times or as long as you need until you come up with Newton's second law of motion on your own, great. You know, then you would have discovered yourself. That would have been inductively figuring out what you learned. But instead we don't have that much time, so we say, here's Newton's second law, F equals ma, here's 20 practice problems, and you never really got a chance to, well, how did that happen and what was the relation? You didn't get a chance to discover, right? But what we're talking about is your ability to discover, and then we have to, you know, get to that. And then finally, self-awareness, emotional intelligence, which that's controlling your own emotion, being aware of other people's emotion, and sometimes even being able to manage the emotion of people around you, like that's another level of it. Okay, so these are not all, but it's a lot of this kind of what pushes you out in this dimension. Okay. This is basically my inductive learning pitch. That's you as the kid, you looking at the result and saying, why did that happen? It's a basic idea of, you know, what we're looking for. You can use cause and effect, and you can use comparing patterns. So how do you teach this? How do you put all this together? The basic thing is that you have to do it in situations. So we put people on projects, and there's a background where we say, here's a case. maybe an experiential lecture, and then but you're going to make decisions, and this self-reflection is basically the key. So you look at where you are and you say, was that a good idea to do that? Is that working well? But also, what's the problem? Is the problem me? Is the problem that I'm not interacting well with people, or is the problem that I don't have the right logic? You have to learn in all the dimensions. And so that's the inductive learning plus the journey. That's just combining all of this together. So we tried to come up with some sort of branding and approach that would put projects in this way. And this is what became what we call Berkeley Method of Entrepreneurship. That you can learn it only while you're trying to do it, that the instructor hosts the environment where this type of learning happens, that we're working on your behaviors through this self-reflection and through exercises that you do. Don't focus so much on just getting the A, but are you achieving that goal? And we leverage real-world competition wherever possible. So if all the teams compete to be the #1 to have the prize, that's like in real life. You're competing for something, and you learn all these things along the way. Trying to make that classroom environment as much like the real-life environment that you can possibly have. Okay, we've been doing that for a while, so I have some experience with it, whether that's deplastifying. These are all different kinds of challenges that we've done. I won't spend time explaining them all, but it's what we've been learning how to do over some time. It's a teaching method. Okay. There are behaviors. I won't go through all of these. I just want to give you. There are mindsets. That means you think certain things are positive. There are behaviors. Those are actions that you do. People can see your behavior. They can't see your mindset. But when those two are not aligned, it looks like underconfidence. So it's like you're acting one way, but you're thinking another thing. So those little hesitations translate into you seem a little uncomfortable with things. And if this was a longer talk or whatever, if it was a whole class, this is kind of just pedagogy kind of level discussion. There are ways that I can explain how you fix a behavior or how you fix a mindset. Those are different. One is logical and one is through repetitive pattern. Okay. All right. Okay. So concepts of journey, inductive learning, behaviors, they apply to new ventures. I'm going to give you this example. It's a faculty example. So here's Ian SUTARDJA. In 2015, I think, we invited him to the lecture series. We picked him, it's kind of along those lines of a person who's technically very strong and then becomes a CEO, and in fact, he's founder of Databricks, which is a very significant company now. Creator of Spark, basically, or offering Spark as a platform. But he starts off here as a very academic, theoretical person. He doesn't start off as the person that you think of as like CEO type. And so we thought, let's invite him. I wonder what he's going to say. Okay, I'm obviously setting up that slide. I had no idea what he was going to say. But I was like, then he starts talking, and literally this is what he said. I'm like, oh my God, you're validating like exactly what I'm saying. Where he says, I learned, it's almost the beginning of his talk, that a startup is a journey. This idea that it's a path, that you learn on it, so forth. And then he gave, I won't give his whole talk or anything, but then in his talk he explained the parts, the adaptation, the things that happened there. And I just only am going to like pick out like a couple things out of his learning lessons. And one thing that he said, okay, when you adapt, that equals learning. It's not mistakes, no problem. He said the journey can be rewarding and stressful. And you say, why is it stressful? It was mostly the people relationships. When people come to you and they want to be part of what you're doing, and then things are not going well, or you have to let them go, or whatever. It can be their friends, but you also have that tension, going on. So there was that. Then I thought this is really interesting. Team. The team must be great. Okay, and then he says, so what do you think it means to have a good team? And everyone is thinking, oh, that means the smartest, best person in every possible function. And he says, no, you might think that, but that's not it. Team, a good team, means people who trust each other. I'm going back to the same principles I'm saying. If they're really aligned and they're trying to do the same thing, then that's trust. You know, that trust of the people is the critical thing. And he says, I learned my job had changed. Before, my job was to be the smart person with all of the answers. And when I took this job, my job changed to be the person that picks the people that can make this team that will trust each other. Will they fit together? That became the new job that he had to learn to have, to be able to be this leader and to do these things. I also thought this one was really interesting. Listening to customers, he says, I learned that customers know better what they need than me, which was apparently hard for him to say. But then he balanced it very nicely, and he says, but I realized I knew better than them on how to give that to them. So, you know, it's like I'm willing to realize that you know your own situation better. I can't just come in and say, this is what you should do. But once I hear it, I can tell you the better way for you to achieve it. And so it was like, I thought that was, like, I liked it. I thought that was great. Okay, one slide basically says, we've had some success with this. I'm not going to overdo this or anything. A couple data points. These guys acquired by Facebook for $100 million. I think this company is almost $1 billion worth, GoGo Van. I could tell you a story. This company was on the cover of Time magazine. Christine Ho, who I worked with doing Imprint Energy on their Series B, listed top 50 technologies in the MIT review. Anyway, and I think this is hardly all of them. I think we're busy putting together lists of like others. I'm not overdoing this. I just want to say there's at least some people that have.
I would be interested in hearing some comments that you have about some of the experiences or challenges that these groups had along the way that, you know, that you found interesting or.
Yeah. Okay. All right. I can tell you all their stories.
Okay.
I know.
Okay. Pick
you know,
a couple maybe, one or two. Yeah.
Yeah. Sure. Like, okay. Let's start with Christine with Imprint Energy. I had my office on the 4th floor in Citrus there, and one day she comes in and she's like kind of distraught, and she's like, I want to take my research and commercialize it, and I'm basically stuck with getting the IP out of the university. And I'm like, this is something that I've been wanting to not touch for like the entire time that I've been here. Like, I just want to avoid that topic. But like, here she was, like right at the door. I'm like, okay, fine. Let's look into it. And we ended up basically doing case analysis on all the other Berkeley companies that had gotten their IP out and what happened in which order. We wrote that into like a report, a pretty significant report. I, and actually Bev Alexander from the Clean Tech to Market program were co-authors on that. There might have been one other person, I'm probably forgetting somebody. But anyway, and we basically figured out like all the paths. We actually got IPERA to be part of that report. And in this whole process, we actually helped her. So I learned how it works. And we used actually the case examples of people at Berkeley who had figured it out. But like that was a challenge in her case. And I actually wrote a chapter on her in the book, in the Innovation Engineering book. And so I have some idea about what she learned, you know, after that, also about leading. She learned a lot about not everybody basically wanting to talk to the top decision maker and not talking to all the people between in order to like not waste her time in building the company. This guy, GoGo Van, Stephen Lamb, that is a great story. This guy was literally cleaning bathrooms in Chinatown as a student here. He had no money. He's from Hong Kong. He was just trying to pay his tuition and doing whatever he could. That job was so painful and annoying and difficult that it forced him to find these other mechanisms to fund himself. And it was around the time when the iPhone came out. So what he did was he got all his friends to buy the limit on iPhones, which are 2 per person, and built this kind of logistics flight carrying system to resell them in China. He would like take them over, and so it's like 500 here and 1,500 there. And he used that to fund he built this thing, and then GoGoVan was basically the next incarnation, but it's basically a logistics company. All the stuff that he learned there, he basically translated it. It's basically like Uber for package delivery. Anyway, okay, I'm not going to take, well, I won't do it, but like they're all different in a way, but what Christine learned on the behavioral thing was one thing. What he learned on the behavioral side was partly out of pain, but you talk to him and you'll see those behaviors like right away. His ability to be open, to create those relationships, they're there. Am I answering the question?
I think so, yeah.
Okay, all right. Okay, because I want to move on. Okay, so I'm just going to reframe what's happened over a period of time. Teaching 1.0, when 2005, it was basically we learned how to teach case studies. That was new to me. But what we would do is we would take cases, basically Harvard cases, apply them, kind of filter them by our own experiences, whether that would be useful or not. But we would bring people from the Valley who were in those cases into the classroom. That's what actually got the center to be very popular. So because our networks were good, we would bring Michael Marks, or who is CEO of Flextronics, we would bring him into the classroom. And everyone wants to take a class where that person, you would agree to that, right? Like if you want to take a finance class, wouldn't it be good if Warren Buffett showed up, right? Like it's just like has a big draw. And then after a while, we're like, oh, you know what? Those people we're inviting have these mindsets, they got the behaviors. Like, what is it about those? That turned into the paper, Berkeley Method of Entrepreneurship, the paper where we wrote the behaviors down. And that got us to Challenge Lab. Could we teach those behaviors? Could we get people to learn them? And I haven't told you this last part of the story, which is where I want to go now, which is what I will explain. So you guys are in DataX, right? You can feel free to correct anything if you think it's not, accurate. But basically what happened is, what I wanted to do was build a data science class that somehow secretly or in a subtle way brought what we learned from this side into this more technical class. And from that, we basically got processes that we use to build labs, to develop projects, and so forth. So I'm going to tell you about the DataX part now. So what is DataX? DataX, it's called Applied Data Science with Venture Applications, IO 135, and there's 290 version. It will become 235, I think, in the next semester. It is a data science class. It's like a hacker's guide. Is that right? Agree? Okay. It's like a maker version. So it's all about making something with data tools. It has a component. This part you don't really know fully yet because it's still early in the class. It has a systems and a signals part of it, kind of trying to combine these, but I'll give you some examples. And it definitely has mindsets and behaviors that are built in, but they're not overt. Most people who take the class don't think they're taking it because they think there's anything to do with mindset and behavior. They take it because they feel it's a data science class, but I couldn't help but bring some of these other ideas into it, okay? Yes?
How much domain knowledge do they have when they take this data class? I mean, to what extent does domain knowledge play a role?
It varies. So some of them have taken Data 100. They've taken, how much background do you guys have?
Python and stuff.
Okay, so in your case, not a lot of background. I mean, you have the prerequisite amount. Some people have taken much more advanced classes, and they really like it for the project aspect. Other people have maybe taken Data 8 or only like kind of the minimum, which is that, and statistics and a little bit of linear algebra. And so I have a wide range, actually. Okay? I'm just trying to see if I've answered your question. I think I did. Okay. So these are examples: detecting fake news, or predicting just about anything, figuring out what path to walk in Berkeley to avoid crime, how much an Airbnb should rent for, all those kind of prediction, classification problems. They're very common. So is building a data pipeline. So is, you know, doing like a web crawler to collect data of a certain type. All of those are common types of projects. We've had also like whether you should have knee surgery or not based on your x-rays and things like that. Those are all types of projects. Now, this class is intended to be different than other kind of like, I'm going to say standard computer science classes. My analogy would be if you're building a house, I think of most of the computer science classes, the capability to build the tools. So if you want to build Spark, there's like classes that give you all of the background to be able to do that. Or if you want to build any of the other, like if you want to, yeah, like it's very hard to build those tools, right? But that's a different thing than using the tools and architecting systems. So I just basically shifted it to the applied. It's not quite financing your house. That's our other kind of more entrepreneurial topics. But in between these two, there's a big thing that happens in the use of tools. And I think this goes really underappreciated. It's one thing to know how to do something, even theoretically. It's another thing to know how to use the tools. And when you have powerful tools, and you know how to use them, you can do a lot more. You all of a sudden you become very effective. And that plus architecting systems, there's a big piece of value there. That's where I've been going with this class. It has 3 pieces. You know, it has the open source tools, it has theory, and I'll show you some examples of that, and it has this open-ended project. You can basically pick almost anything you want to do and work on it. You can come up the learning curve to work on it. This is the way the class is built. So in the first 5 weeks of the class, you're supposed to come up with an insightful story. Now, in some of our other classes, we spend like 80% of the time, by story I mean narrative, I mean slide presentation, venture pitch, like all of those types of things are story. So in this one, we don't give you that much time, right? We give you just like a week or two to think about it and then to put something down. So the story doesn't have to be a fantastic story, but you come up with a story. And then you write that story in something called a low-tech demo by week 5. And so you show from your story what you're going to build, but without code. So the slide version, 5 different views, like the customers, like the user interface, the purpose, the architectural view. There's like 5 different views of what's in it. And then the solution is built through iteration. So it's like basically 1 week or 2 week agile sprint intervals, and then demo or die. That's supposed to be the parallel to publish or perish or publish. It's an MIT term. I didn't invent it. But it basically means that's your day to show. Nobody died in the class. I just point that out. Okay, so far. All right. All right. And so, but what you can see is, I believe in story comes before execution, and I think execution is a bigger deal. But I've tried to put that framework even into this, quote, technical class. So like it's built that way. Here's some examples of tools. So Python, NumPy, Pandas, if you're not familiar, scikit-learn, which is your basic ML stack. This is your basic table storage vehicles. Map visualization, matplotlib. We do TensorFlow with Keras typically. And sometimes we don't do so much of this anymore, SQL with Pandas, natural language processing and NLTK and others. We have a little bit on Spark at the end, but not, it's not a main thing. But it's your basic open source, completely free tool stack. This is what I'm saying. Knowing how to use tools, the ones that everyone uses, is powerful, right? Okay, so this is an example of one of our notebooks. This is the Pandas one. Have you seen the Pandas one yet?
Yeah.
Okay, you can testify to that. Okay, so I would open up a Jupyter Notebook and take you through the code. It just takes time. So what I'm going to do, I just want to show you like what our teaching tools look like at this point. So this is a version of this notebook that I wrote many years ago. It's been updated since then. But how many of you know what Pandas is? One in class, and you, because you're a data science expert. Okay, so let me then just explain it to you. So in the old days, everyone used to use Excel when they wanted to keep a table with all the information. Now, you can do this in computer science in a much more powerful way. So you can take everything that's in your huge Excel spreadsheet and call it a variable. X equals a data frame, correct me if I'm wrong, and then all those things are just referred to under that one variable, or actually object. Then if you want to say x.sort, you can sort the whole thing. And if you want to get any piece of it in code, you can manipulate everything that's in here. And it's very powerful because a Pandas data frame, this thing, can be 1,000,000 lines deep. You know, it's much more fluid, easy to use than Excel, which is like, you know, like cumbersome in a way. So how long does it take to learn this tool? You know, to learn it really poorly takes 10 minutes, okay, maybe an hour. To learn it really well, I don't know, a month or something like it. But quickly, we can get people up to the speed, and we just kind of walk them through the tool, right? So knowing the tool isn't everything, but see, these tools are powerful, and that's the point. Okay, then I'm going to show you another idea, which is that while I showed you all the tools, and we've written notebooks for all of these, and like I said, I could go to GitHub, and I could show you all the different notebooks that we created. There's also this idea of I'm trying to mix in this class systems and signals and data. And this is the part where I might accidentally like bore everybody to death. I'm going to do my best not to. But there, to me, in data science, there's kind of like 3 views that you have to be able to easily switch between. So there's the data view, and it always looks like a table. So you've got all your data in tables. Then there's a math view, where it's being plotted, and you say what model, what line fits through that, how do you think? And then there's a systems view, where you're like, okay, I'm going to put in something, and I'm going to get something else out. And this same thing, like when you look at one, you look at a formula, like what does that look like in the table? If it's in the table, what does that look like as a system? I want that idea to be in this course, the like easy to switch. So if you're doing prediction, maybe you have this table and you have these numbers, but you don't have those. That means 8 and 10, you're going to be putting in the system, and you're going to get the question marks out. You get the idea. You can switch back and forth between these views. These are now just some quick examples. I will try not to overdo this. You know, we might ask people, okay, here's a table. What's the best linear predictor? I'm not going to take you through the detail of it, but we say, okay, well, just in math, we could do it. And the basic idea is that you could, right here, figure out where is the mean x and mean y of these data points, and then, you know, using the ratio of the covariance over the variance, figure out what the slope is, and you get your best linear predictor. You did this already, right?
Yeah.
Okay.
Yesterday's
Okay.
class.
All right. And then we show you the same thing in code, and the code version looks different than the math version. But you get, you know, like comfortable, because like how you do it in math and how you do it in code, just there's a natural like difference between them. Here's another kind of, the only reason I have this section in here at all is just that I want you to see that this is actually a data, like it's not a story generating class, it's not a, you know, like there is data in here, okay? This is a practical example of correlation. Again, you've got a table, you normally see it this way, and if I say, okay, what's correlation on this table, do you have a comfort in understanding that you're not going to get correlation unless you have 2 columns? You need 2 columns in order to have a correlation. Now, I'd say every one of these points, 15 and 12, if it's here, do you have a sense that that's in the quadrant that adds to the correlation? Do you have a sense that if it's over here, it's actually going to, you know, compared to where the mean x and y are, do you have a sense how it's going to take away from, subtract from the correlation? And in fact, and like not to teach all this now, but that, you know, if your point is here and you have that much area, that area is actually exactly how much you're adding. The physical representation of area is what you're adding to the covariance, and then that gets normalized and turned into the correlation. So this, right, I'm glad that the data person is nodding. So, okay, so this like kind of practicality of, do you see the table and what it means in the math is, you know, part of the theory aspect. But then there's more, and I say, okay, well, where did that thing come from? Maybe that came from continuous signals, so you had this data, and then you had a window, so you had a window of time. Was that window in the middle? But when it ended up in the table, that ends up here. And then when you're going to run your correlation, what are you running it on? Are you running it on this window or another window? Like, do you have a sense of, like, data's not just data, like it appears in a certain format, it ends up in a certain place, you hold it in a way, and now, if you want to do that correlation matrix, you don't write all that code, you only use this data frame.core. You use one variable, but you have to know what you are taking the correlation over. And so if you do it on this table, what do you expect to happen? Do you realize that all of these things have nothing to do with the correlation? It's only those columns, so that's why you get correlation. Okay, I may be overdoing this, but you get the idea. Let me just, only for the faculty's interest, go a little bit deeper here. I also wanted to put in things that are more about spectrum and like linear time invariant system kind of ideas into this class. So, you know, Fourier transform and intuition, you know, here's a signal and that's what its transform would be. You know, if I, you know, change this, then I get a different thing. I'm doing this very fast. Okay. I would, you know, and then just like in what is it, MATLAB, just like in MATLAB, the idea that you can create these signals and then know the sampling rate and so forth, like just generating the thing and doing FFTs, we can do that. But what I would like people to understand is, okay, fine, you did an FFT of that thing, now you've got 150 numbers here. What do those 150 numbers mean? You know, it's not just 150 numbers. And you know, this understanding that the number of samples that you put in is going to be, in the FFT, is the same number that you're going to get out. And that there's a spectrum of frequency that you're covering that has to do with the sampling rate that you're going to see in bins on the other side. If you know what I'm talking about, great. If you don't, it's okay. But so, you know, I'll give you like a try it yourself kind of example. You got this audio for 3 seconds and you had 2,400 samples. Can you say in the first 100 milliseconds, you know, in that 100 milliseconds, what's the spectrum? What are the bins in each, you know, how many hertz are in each bin? What's the frequency range between these points? I just want, like, do you see it as just numbers, or can you relate it to, you know, what's actually happening? And, you know, so like here's the answer. You could basically figure out sampling rate is 8,000, therefore the width of the spectrum is 8,000. I can, all the normal things that you would expect to get practice to it. I won't do this too long. But I can take that and I can say, take a look at what you can do. Let's say you have the whole song. I can take every 50 milliseconds and I can do an FFT, and I can actually develop a picture of a song. It's a very common practice. So if you want to manipulate the song as an image, this is the way Pandora or other people do it. So like we can kind of build up the whole systems view of data, you know, and I can go, like, I didn't put it in the talk, but, you know, ideas of like information theory and how much entropy is in a column or a row or in a column, even those ideas and how that affects decision tree algorithms, they're all, you know, okay, I think I've overdone this part of the talk, but I just wanted, all I want to communicate is that there's also theory. Like, we're teaching tools, we're doing projects, but it's not that there's not theory in there. It's actually blended, what I think, as well as I could possibly blend. Okay, so there's a lot of things, system level ideas and so forth, and I won't read all this. And there's also the way the team, the formation, the way the project is managed. This idea of getting to something you can demo very early and then incrementally building on it. If you take all the ideas that I've mixed together so far, they're built into this now. The inductive learning, the path, the learning while you're doing the project, the reflection part. Even though it's all technical, it's integrated. It's intended to be. Okay. In about a year ago, I think or maybe it's 2, I don't know, then we wrote this paper applying entrepreneurial teaching methods inside advanced technical STEM classes. So I basically tried to take what I learned in teaching the entrepreneurial topics and bring it into a topic where you would never see that type of idea built into it. And that's what this is. This is the website, datax.blog. All the code samples, everything is publicly available. People all over the world actually will reference this site. They teach their own classes, in Hong Kong and Prague, in future in Germany and Qatar. This has become helpful. And so we're having some success with it. You want to see your picture? It's somewhere in here. All right, I don't know where. Were you there that day?
Yeah.
Can you find yourself?
Yeah, my phone was there.
Okay, all right, so it's a real picture, okay. All right, thank you. So anyway, this is, it's a popular class. We had to tell 70 people to stop coming to it. And that takes me to my current interest. What am I working on now? So I'm basically working on a next generation of projects. I'm looking for projects that are, and for the benefit of students, basically. I'm looking for the way that we can bring students into more real life, cutting edge situations, like where, and I'll give you an example, but I want it to have actual impact. I want them to build networks, and I want them to develop skill areas where no book has been written, where nobody knows what's going to happen. That's really like what I am working on, right? That's like how you do that, if anything, would be the question that drives the work that we do. And if I put it this way, we have Berkeley students, we have people in our networks, industry leaders, we have our faculty, and there's something, and I want to know what this something is. And students want skill development and opportunity. Maybe these projects will have life outside, and some of them turn into insight that is fundable research that would bind more faculty back into this box. And this is the basic mechanism that I'm working on. So what can it be? I don't have the full answer. It's not like it's solved or anything, but step by step, I'm trying to get there. And I have this class going on right now, the 5G AI class. I'm bringing those industry people from the CTO offices, AT&T, Verizon, and so forth. I'm bringing the students who have their data science capabilities, but they also are consumers. So they understand things about the phone companies, frankly, the phone companies don't understand. They understand what it's like to be on hold, not being able to talk to the phone company. They know why, they understand, the phone company has a way of thinking, and the consumer has a viewpoint. And so I think when we mix all these people together and come up with the ideas and then build the services that we're going to build in that class, I think the phone companies around the world are going to be interested. I think they're going to want to know, what did you guys come up with? And I don't just think it, I can tell. GSMA people call me all the time saying, everyone is trying to figure out what's going to happen in your class. Everyone is AT&T and Verizon, and all these guys are asking, what's going on there? That's what I want. That's the kind of projects that I want, where everybody in the world is like, wow. And I want the students to be right at that spot where nobody else knows, where they know things that other people don't know. That's what I'm basically working on. I tried to put as much as possible into the book as a process. Never intended to write that book, but I did anyway. This is the version of the innovation engineering class. So the story is half, the solution is the other half, industry perspective on half, project reviews on the other half. So like you see, they're all kind of variations. I could show you another one that's at an executive level. It's done differently. Like we tune these things depending on the audience and what we're trying to achieve. But now you understand the purpose and how this is different. This one is, okay, I think that's good. So for years, people used to say, oh, okay, do you have like a method or a recipe? How do you do this stuff? So I tried to put that in. There's a lot of Berkeley case examples in this book. So students that have done various projects, I've got like 5-page case examples. So in a lot of ways, I think it's also good for Berkeley students to see other Berkeley students that, that did these types of things. There's also executive ones in there too from my executive class. So this site is where I keep all of the tools. So these are classes, and then if you want this tool or you want the navigator, which is our way to manage the project, or how to get your template for the low-tech demo, or go to Berkeley Innovation Index, which is the self-assessment for your psychology, whether it's tuned right. All those tools are now put in one place. That's what that is. Okay, this is an example of the process. Articulate your initial conditions and then your story, and then manage it with this innovation navigator that's to execute while learning, and then learn where you're going to hand this off. This is a slide that kind of explains, I'm going really fast because I want to finish this part and also like have dialogue here. But so in the project, I want people to separate regularly. This is what's working and this is not working. And then 2 weeks later, do you see a difference? Do you have more things working? Do you have new things that are not working? This reflection process is kind of like built in. It's like painting the Mona Lisa but by numbers. We're kind of forcing you to have what would be the natural innovative instinct. And then after a while, you develop that behavior. You don't need this anymore. You just think that way. Okay. This is what that chart looks like. So every couple of weeks, you're writing what's going to make this successful, what's working and known, what's not working, advisor comments, reflection, I think the problem is X or Y. We looked at a lot of different processes. We tried to borrow whatever we could to make this one. I have other projects that I'm experimenting with right now, making more and less success with different ones. And my closing comment here, so this is a summary. This is the whole summary. Motivation, I believe in the student potential. I want to develop world-class opportunities. I want them to benefit from the right mindset that will, to have that kind of success. I think the students they've worked very hard. They are very smart. They didn't just randomly get here. And now I just would like to further their success. That's bring them more opportunities and make sure that they're thinking the ways that they got here are not necessarily the ways that they're going to be successful in the next step. And so what is the way that you have to think to grow to be able to be successful in the next step? And that, unfortunately, only comes from experience. You have to be able to look back to add that in. So that, and I just want to see them have a real impact. The concepts that I've been trying to communicate through all of these are journey, that all these projects are journey, inductive learning, how you learn it in the process, that technical tools, they're very powerful, and you have to balance both tools and theory. Story first, it's a very important, so many projects start without story, just requirements, just someone told you to do something. You need story first. Incremental execution, I showed you more than one example of that. And then, of course, behavior and mindset, which is how we started this whole conversation. Okay, so I think I'm still on time or whatever.
So I think we have a little bit of time for questions.
Yes.
You use the word story a lot. is there basic parts of a story, or can you explain a little more what you mean by that? You know, there's a beginning, ending.
Yeah, okay, so there's a lot of kinds of story. But, you know, I can say.
Elements of the story.
Yeah, I mean, so I'll tell you what they are, but first I'll just define it as some sort of narrative that lets you know what's the target of what to be done. So one type of narrative is what's called NABC, need, approach, benefit, competition. Here's the need, here's the approach that we're going to use to solve that need, here's the competition, benefit, and then here's the competition. It's like, okay, so in 3 or 4 sentences, you can get people to get sharp about what they're suggesting. Another, you know, very common story version is, I'm doing Uber, but for bicycles. Or like when you take something that is working and you change a variable and you use that in your communication. Sometimes a demo is actually a story. So you're like, okay, this is what it's going to look like, or you know, a picture of what you want to make. That can actually represent story too. Amazon has a 6-page plan before they do projects. That's a story. You know, I think one of the very powerful versions of story is actually scoping business model. And by that I don't mean filling out a chart and things like that, but looking at the landscape and saying, there is a box that we want to fill, but if we fill it, how does the rest of the landscape react to that? You know, is it like everyone's going to say, oh, you cannot be in that space? Or is it, we didn't want that anyway, I'm glad you're filling it. So understanding where your scope is makes a big difference about whether the rest of the story can happen. All those are ways of like, you think of it as a plan, but it's told in words. So that's what I call story. Okay. All right. Yeah.
So one thing you mentioned is how DataX is intended to be like a data class with these aspects of innovation and entrepreneurship kind of under the hood.
Yeah.
So I'm wondering if you can elaborate more on how these aspects of innovation and entrepreneurship are taught or executed throughout the class, whether it's through the project or
Yeah.
other
Okay.
means.
DataX is not supposed to be an entrepreneurship class. It's a data class, but it teaches a few innovation behaviors at the same time. So the goal is not to start companies. It's not that type of thing. But it is effective in that it's kind of more like Jacobs, but for data. So if a company comes out, fine, but you know, you're really after like, can you make the thing that somebody can appreciate some aspect of it? And that's what we're doing with that. Yes?
Yeah, one question is more not so much related to your slides, but just kind of more of a philosophical question. So now, partly because the MBT students start out in the engineering school, and then they only take business class later, there's this perception that they really identify as engineering students who take a couple of business classes. How can we flip that model and make them really both, you know, serious business students and engineers, so that it's really much more of a cohesive program?
So I haven't had a lot of time to think about that.
You know, I mean, to be honest, as the dean of the business school, that is my #1 concern.
Okay. I want balance. I don't want it to feel like one side or the other. I would certainly support everything to do that. How can we do that? I don't know why the classes are taken in the order that they are. I wasn't in that part of the discussion, like, you know, at that time. Maybe you guys would know more about that part. How can we get more I think you're really saying, how can we get more connection with Haas people into MET? In a way, I almost translate it that way. And maybe the way is whatever projects we do, whatever we have the space to do, and when it happens, I would just like to find ways to bring the right ecosystem together around that set of students.
believe there are a couple of classes that students, they're joint classes that students take fairly early on. But there's not stable instructional support in that process. And so I think once we do have an MET director on board who is interested in teaching those courses, that would actually provide a lot of glue that doesn't really exist at the moment. I mean, that's one channel for it. Any other questions?
So actually, I'm a student in your class.
Okay. Thank you.
Because I think this course is really experiential, right? So for this kind of stuff, it's really difficult to measure because students have different expectations. How can we make sure that students are satisfied? Okay, I've learned something. I have some takeaways from the class, from the project, from the experience. Right?
Let me make sure I'm understanding. You started by saying this class is experimental. What was the word? Experiential. Yes, yes. Okay, right. It is experiential. And then the second.
So it's difficult to measure.
That's a statement.
And the students' expectations are different from each other.
Yes. Okay. And so you're saying how do you measure the effect of it at the end, right? I think in some classes you can say study this, solve this problem. If you get the answer right, then that's the measure. But in a class like this, the result of what you make, what you show, is one part, and also the result of what you can reflect about what you learned yourself is an important part. So there's look what we were able to do. That's a big one. And then how did we do that? You know, did we already know how to do it? There were parts that we didn't know how to do. How did we overcome what we didn't know how to do? That part of the journey is the other important part. And it's not that we're just wanting you to fill that gap. What we're wanting you to know how to do is to learn to fill it the next time. So if you reflect back on, well, how did I figure out how to do it when I didn't know how to do it before? That pattern is what you're going to need to, overcome when other people aren't able to. Yeah. Okay.
Well, thank you very much.
Okay.